Hello. In the first lecture of this course, we take an overview of the hexadecimal number system. In this video, we will take more details about the hexadecimal number system. The hexadecimal number is one of the number system which has a value of 16, and it has only 16 symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F, where A, B, C, D, E, and F are single-bit representations of decimal values 10, 11, 12, 13, 14, and 15, respectively. Whereas the binary is a simple kind of number system that uses two digits of 0 and 1, value of base 2. Since digital electronics have only these two states, 0 and 1, the binary number is most preferred by modern computer engineers, networking and communication specialists, and other professionals. The hexadecimal is used because large numbers that represented using fewer digits, for example, colored values and MAC addresses, are often represented in hexadecimal. Additionally, hexadecimal is easy for humans to understand than binary. Programmers are often use hexadecimal to represent binary values as they are simpler to write and check than when using binary. So in this table, we typed out digits of decimal number and its equivalent digits in hexadecimal. Then we write what is equivalent to them in binary number system. Let us take an example. Convert the hexadecimal number F67.19 to a binary number. From the above table, the hexadecimal number 7 is equal to 0111. The hexadecimal number 6 is equal to 0110. And the hexadecimal number F is equal to 1111. And for the fractional part, the hexadecimal number 1 is equal to 0001. The hexadecimal number 9 is equal to 1001. So the hexadecimal number F67.19 is equal to 1111.01111.00011001 in binary. Let us take another example. Convert the binary number 10100111.0110101 to a hexadecimal number. First, we will be grouping the binary digits of 4. We start with the integer part from the left of the decimal point and take these 4 digits. From the table, these digits are equal to B. Then we take the next 4 digits. From the table, these digits are equal to 3. Then we take the last group, these 3 digits, and we will assume there are a 0 to the left of them, where this 0 is not changing the value of the number. So from the table, this group is equal to 5. Now we will convert the fractional part and starting from the right of the decimal point with these 4 digits. From the table, these digits are equal to 6. Then we take the last group of the number, these 3 digits, and we will assume there is a 0 to the right of them, where this 0 is not changing the value of the number. So from the table, this group is equal to A. So the number 10100111.0110101 in binary is equal to 53B.6A in hexadecimal. This course is sponsored by the Logic Kit app, where this app is made for everyone who are involved in studying the computer. With the Logic Kit app, you can learn and solve number systems and Boolean algebra with step-by-step solutions. I will leave the link to download the Logic Kit app from the App Store in the description. Don't forget to subscribe to the channel, follow us on Facebook and visit our website. All links are in the description.